Hey guys, so this video is for anybody that was gone Friday, April 22nd. Um, don't have any assignments today, but we do got some pretty important notes going forward. So as you can see, we are now into Unit 7, our chemical reactions. And so that's where we're going to start taking everything that we've learned about, okay, how do we draw atoms, molecules, how are they represented, what does this all look like? And now what happens when they actually react, because majority of the world around us is all chemical reactions. Okay, and so now we're going to see how we actually apply that stuff. So before we go any further though, we need to make sure we understand we got a new cell phone headphone policy. So yesterday was just a bad day for people just being disrespectful. So basically our new rule is, if I see your cell phone out at any time during class, that's just going to be an automatic referral. I'm going to call your parents. Okay. It's just kind of become a joke. I tried to be patient with this, and say, oh yeah, it's the last minute or two of class. Somebody's done with their work. Tried to let you guys be mature, but apparently we can't handle that. So we're switching to this. So basically it's bell to bell. So basically if I see your phone out at any point after the bell rings or before it rings to dismiss you guys, that's automatic referral. Okay. Now, again, like normal, if you got stuff going on outside of school, somebody's going to be trying to get in contact with you. All you got to do is just let me know. But other than that, if I see it out, I don't care if it's changing a song. Well, we won't need to be doing that anyway, but it doesn't matter. If you're just checking it, just checking the time, that's going to be a referral. Okay. So absolutely zero tolerance on this. So same thing with headphones. No more headphones. You need to be present. You need to be in class. The only time we'll use headphones is if we're watching like an Edpuzzle video. Okay. So just be very clear on that. Yeah. So let's do better. So today, basically what we want to do is we want to make sure we understand how to identify the number of atoms in a compound. So there's a test question on this. And then we're going to be able to identify the parts of a chemical equation. So our warm-up question, you can do this, is basically how do you know? How do you know how many atoms are in a specific compound? Like if I said H2O, or like on the test, K3PO4, how many oxygen atoms are there? So go ahead and think about that. So what we did in class is we used beads to represent each type of atom, and we basically just built a bunch of different atoms. So when we look at this, what we did is, so I'll say red represents oxygen. So if I have O2, I have two oxygen atoms. So if I built this on with my beads, I would have two red beads. Okay, very simple. That makes sense. Okay, same thing here. Okay, H2O, that tells me I have two oxygens. So I would have one red bead for my oxygen, and then we'll say two blue beads. Okay, there's my H2O. Okay, same thing here. These ones are pretty straightforward. So I'd represent this with two nitrogens, because that's what that means. I have two nitrogen atoms, and then I have three oxygen atoms. Okay. Um, and so as long as we understand that that subscript is what identifies how many of each specific atom we have, then we're good. Okay. Those ones are simple, but then it gets a little bit more complicated. This one's not too bad, right? Here with K3PO4, this was the one that was on the test. Okay. So with potassium, we can see I have three potassiums. Okay. Whoa, that was a bad circle. I have one phosphorus that I'll represent with this beautiful orange color. Okay, one phosphorus, and then I still have four oxygens. Okay, so that four in here only applies to the oxygen. But as a whole, my phosphate molecule is this. PO4 is a phosphate molecule, or a polyatomic ion. Okay. So now let's take that and look at what it means when we have something like MgNO3. Okay. So magnesium nitrate. So with magnesium, nothing different here, right? We can represent magnesium just like this. We got one magnesium. If we don't see a number, remember, we just imagine that's a 1. Okay. Then let's draw one of our NO3s. Okay, so nitrogen, let me see here. So I got N and then three oxygens. okay? So I have one NO3, but this applies to this entire NO3. So that means I have two NO3s. So we would show that with another complete NO3 molecule, okay? So now when we look at our totals here, what this tells me is in this one compound, magnesium nitrate, I have one magnesium, two nitrogens, and six total oxygens, okay? That's very, very important. Why is this so important to know? Because when we get into balancing chemical equations, we are not necessarily just, we're balancing each individual atom, right? So we have to have the exact same number of oxygen atoms going into the reaction as we do coming out, okay? So we got to make sure we can really understand how many we have. So we're going to keep practicing that, okay? So now, again, if we want to, let's add this to our notes real quick. Okay, so again, just the symbol tells us that what type of element it is. And remember, when we see a capital, if we see capital N, capital O, that's two different elements, okay? A lot of people on the test wanted to try and find an NO, right? So when we see two uppercase or two capital letters, those are each their own individual elements. We got nitrogen and oxygen, okay? Subscripts, okay, those are going to tell us how many of that specific atom we have. And again, no subscript just implies that we have one, right? So that's why we say magnesium, we have one magnesium, we have one nitrogen, three oxygen here, okay? And then finally, if the subscript is on the outside of the parentheses, that means I have two of that entire molecule, okay? Now, it does not apply to magnesium. It is outside the parentheses, so this two does not apply to magnesium. So let's go ahead and add that to our notes. So then go ahead, try and make sure we understand this. How many of each type of atom do we have? So just make a quick check, okay, and pause the video. Okay, so if you did this right, we can see that we have three magnesiums. We should have two phosphoruses and a total of 8 oxygens, right? Because I got two complete PO4s or two phosphate molecules, okay? Now, next thing that we want to do is go ahead and go to Edpuzzle or go to Google Classroom and open up the Edpuzzle. Take the notes just like it says it's going to talk to you about chemical equations. Pause this video while you do that. All right, so if you watch the video, basically what a chemical equation does is it tells us it's going to explain a chemical reaction, what went in, what went out. So on this side, we have our reactants, okay? So we can think of our reactants as like ingredients in cooking. What are we going to put into the recipe, or what are we going to use in the recipe? And then on this side is our products. What's going to come out? So if you're baking a cake, right, you got your sugar, you got your flour, you got your eggs, you got all those different things, your vanilla, baking soda. What goes into that? Well, what comes out on the other side is this gooey, fluffy, delicious cake, right? So we have reactants on the left, products on the right. This plus sign is telling us what are we combining? We're combining hydrogen gas with oxygen gas, and it's going to yield or produce H2O, good old-fashioned water, okay? Then the last part of the video talked about coefficients. This is kind of the trickiest part, is why we use coefficients is we have to have specific amounts of compounds or elements to make this work, right? And that's because the law of conservation of matter. We know matter can't be created or destroyed, so we have to have the same amount of matter going into the equation as we do coming out, right? So what this tells me, the coefficient means I have two H2 molecules, okay? So if I think about that, each H2 molecule has two hydrogens, so that gives me a total of 4 hydrogens here, okay? Same thing over here. I have two complete molecules of H2O, meaning I have 4 hydrogens total, and I have 2 oxygens. So we could build that with our bead molecule, right? We'd just be building 2 complete H2Os, okay? So the coefficient tells me how many I need. And this is what we're going to get into with balancing equations. So the coefficient is what we're going to use to balance the equation, satisfy this law of conservation of matter, okay? So just make sure we have that stuff in our notes, and then you'll be good to go for Monday. Okay, bye.